Hi, people.
Hi, Moby. Are you guys excited to do some math?
Always.
Define excited.
Thrilled, ecstatic, looking forward to it.
Oh, okay, so by excited, you don't mean obligated.
I'm glad that's where our friendship is. I'm glad that you know the obligations, and I appreciate that. Okay, well, we know that was it last week when you released your new album?
Sure.
Okay, well, when was it, Moby?
I think it was last week. Yeah, it actually was last week.
Okay, so last week you released your new album, All Visible Objects, and can you tell us a little bit about the album?
Sure. I mean, I make my records largely by myself at home, and I hope that I'm fully aware of the sort of pointless absurdity of releasing an album in 2020, because like for the most part, no one really pays attention to albums, but people especially don't pay attention to albums made by 54-year-old guys who refuse to tour. So I love making records. Once I release them, I don't really pay that much attention to them.
Okay.
Why do you refuse to tour?
Because I started touring. The first solo tour I did was in 1991, and I toured constantly from like 91 until about 2014.
Oh, okay, so you're just done.
Yeah, like the repetition of it. I don't want to complain because no one wants to listen to a middle-aged musician complain, but I just am thrilled to not be on tour.
Yeah, that makes sense.
But you still get to make the beautiful art, and I heard that it's doing very well on iTunes, so congrats.
Yeah, I mean, for the people who still buy albums, I guess they seem to like it.
Yeah.
So, and my goal is if it makes any money, the money goes to animal rights organizations. So here's hoping it makes a little bit of money.
That's awesome.
Yeah, that's great. Well, I'm going to go ahead and share my screen because I thought we should do a little math with the new album. So firstly, if we let X equal the number of minutes,
let's read the problem.
Okay, excuse me. Natalie, will you please read the problem?
All right, so the following data set includes the length of each of the 11 songs on Moby's new album, All Visible Objects. And I think these lengths are in minutes. Is that right?
Yes. So if X is the number of minutes, with decimals, of course, we can have a partial minute included, then what kind of variable is X? Would you guys think of it as qualitative, like a categorical thing, or quantitative, a numerical thing?
I mean, you could make a sort of semantic argument for both. I guess on a more literal level, unless I'm missing a trick question, it's quantitative.
Yeah.
Yeah. It's quantitative.
But it's also qualitative linguistically because there's no such thing as a minute. Like you can't go and find a minute anywhere in the natural world.
Right. Okay.
It's an arbitrary unit of measurement that does have qualitative connotations, but ultimately at its most reductive, it's quantitative.
I love that was deep, and you sound like a philosopher / one of my students trying to argue for credit on a quiz question they got wrong.
Oh, no, I'm just wondering if these are dumb questions or if they're trick questions.
No, they're not trick questions. It's that basic. We're just laying a solid foundation. So
Great.
It is.
So I don't need to try and sound smart.
What if we were like, hey,
it's not my strong suit anyway.
No, it is. You're good. But what we were not trying to make you say quantitative, and we weren't going to say, no, it's qualitative, Moby. Minutes aren't real.
Technically, they're not, though. Yeah.
Right. But this is a numerical measure. So it's something that we're measuring numerically. You give it a numerical answer back when someone asks you, like, how long was the song? You don't say, like, purple. You're giving back not a description in like a name, but in a measurement. So that's what makes it quantitative. And then once it's quantitative, we have to ask ourselves if it's discrete or continuous. Natalie, can you remind me what those two words mean?
So discrete would mean that we could count it by whole numbers, right?
Yeah, it has to be a whole number. So like the number of people in this conversation is 3. Like we can't have 3.5 people, even though Moby's like partially clocked out already. So it has to be whole numbers only. Continuous though, what can that do?
That can be any number. That can write any value between 2 whole numbers.
Mm-hmm. So decimals and fractions are okay. So what is this scenario, number of minutes?
You're kidding, right?
Nope.
Okay. Forgive me for stating the obvious. It would be continuous.
Good job. Okay. Now we're going to determine the mean song length. So like on average, what was the length of one of your songs?
Unless I'm mistaken, it's been a long time since I've done math. I thought that was you add them all up and divide them by the number of individual units.
Correct.
That's right.
So add them up. And I'm not going to take the time to actually show all the work, but I'm adding them all up. And then how many total songs are on your album?
11.
Yeah, that's my lucky number, Moby. Why are you so obsessed with me? My birthday is 11/11. It's like you're stalking me.
You're not
down.
looking at my hand.
I know, you're so obsessed with me.
Yeah. You should
okay.
see the tattoo. You should see the tattoo I have on my back.
Ooh, a tramp stamp?
Yeah,
No, it's a picture of Lindsay riding a unicorn that looks kind of like Dexter with a horn on his head.
That makes sense.
Okay.
So
go ahead.
So we add all those up.
Yeah.
Correct. Divide by 11, and about what do we get? Yeah.
Okay, my guess is that if you add them all up and divide them by 11, it'll come out to like somewhere around 6.61.
Yes. Good. So 6.61, and the units on that are minutes.
Right.
So that's your average length. So when people come up to you and fans approach you on the street and they ask this question, you're now ready to answer. Let's scroll.
So it means like 6 2/3 minutes.
Yeah. Cool.
Which is also a relatively easy, in terms of like 2/3 of a minute would be 40 seconds, correct?
Yes.
Yeah.
You like mental math. It's great. Okay. Have you ever heard of a standard deviation?
Yes, I have. Only in charts, graphs.
Uh-huh.
And so when I meet with my financial advisor, he always talks about standard deviation. So for the last 15 years, whenever we've met and he's talked about standard deviation, I have nodded my head, pretending to know what he's talking about. So I'm very familiar with the term standard deviation. I have no idea what it means.
Okay, well, what it means is it's like we just found the average 6.61 minutes. So like if we look on a number line and we put 6.61 minutes, that's your average. And you know what? This is the population of all of the songs on your album. So I could honestly probably change that notation and use my population notation. Do you agree, Natalie?
Totally.
Yeah, since we're talking about a population, I'm going to go ahead and be consistent and use that population notation. But so here's our mean. The standard deviation measures the typical distance of each data value from the mean on the number line. Like how far, picture your 11 songs. None of them are exactly 6.61 minutes long. They all stray from that a little bit, some more than others. So,
that makes sense.
Yeah, so it's basically the typical distance. That's like a synonymous. Typical distance kind of makes more sense to us. Standard deviation is just like a fancy way of saying that. A data value lives, so a song length is from the average song length. So how much do they stray from that? So we're going to go ahead and calculate that by hand.
Okay, so we'll start with just filling out that X column that you have there with all of our data points.
Yeah, so
Yeah, all the song lengths.
Okay, so I like to list them in like a vertical fashion. And then Moby, you can get ready to do some of your mental math because you're the only one in this group that's actually good at that, which is kind of ironic.
And you're listing them in order from least to greatest, which I think is nice.
Actually, I'm not, but thank you for.
I thought you were. Oh, yeah, see, or you're not. Okay.
I'm not, but see, that's exactly what I was talking about, Moby. We need you.
Yeah.
This is the quality of work I'm talking about. So our mean was 6.61.
Yeah.
So like I like to note here, if we take each data value and subtract the mean and kind of keep track of that here, one of your songs was 5.5 minutes long. So how many minutes away from the mean was it? So go ahead.
1.11.
Correct. Now, this is going to be.
I sometimes think these are trick questions.
They're not trick questions. This is just decimal arithmetic at this point. But we do want to note that it's negative because that 5.5.
Yeah, 1.5.
Okay. Champ, what's the next one?
Right.
Negative 0.86.
Yeah. I'm just filling these all in now to save all of us the joy that we were getting from it.
Okay.
But here's the thing. We want to think of like what is the like total distance or deviation from that mean. But if we add these up, like if we think of like here's the deviation of each individual data value from the mean, and if we sum them up, the issue is that that sum will more often than not, and especially when you have a population like this, it's going to zero out. And it'll look like we're trying to say that the typical distance from the mean or the total distance in our data set from the mean is 0 when it's not. So that's why the next thing we're going to do is we're going to force all of those values to be positive by squaring each of them. Because if you square a value, the result has to be positive. Even a negative number. Like my mom used to always tell me that if I'm squaring a negative number, like negative 1.11 squared is negative 1.11 times negative 1.11. And she used to say, if something bad happened to someone bad, that was good. You know?
I think you just completely confused anybody watching this video. Like,
why?
Well, okay, you redeemed it with a smiley face, so never mind.
But if something bad happens to someone bad, isn't that good?
I mean, not really, but
yeah, but you're anthropomorphizing numbers, and I think that's what people are confused.
Okay, I don't think anyone's confused, and I think maybe just if you're going to speak for the class, then you need to survey them first. But
okay, survey says the class is confused.
The class is not confused. Okay, are you guys with me that I'm just squaring each of these values?
Yep.
Yeah.
Okay, and then what we're going to want to do...
I'm glad you're not asking me to do that because there's no way I could do those numbers in my head.
Oh, yeah.
No, I didn't do them in my head. Nobody's going to do this in their head. So grab your calculator, everyone out there at home, and then we're going to total these up. But Moby, I know you put that in your head.
And you total them up and then divide by 11 as well, or how?
Yeah, so that's going to come into play for sure. I like that you're thinking that way because you're like, wait, there's 11 values. First, let's get the total. So I know you can do that in your head real quick. Go ahead.
I mean, I'm not a savant, but I would say like probably just shy of 25.
Okay, cool. It's 24.9763 total minutes. But that's kind of not a good job. That's not a great representation of the typical deviation from the mean either, because like none of the data values in your on your album live 25-ish minutes away from the mean. So that's not quite there either. So you were just telling. Oh, go ahead.
Wouldn't you have to square the average as well?
Yeah. So we have to think about like how we just squared something and like. Think about what we just did there is if we squared those minutes, the answer right now is in square minutes. And that's kind of like hard to imagine, especially if minutes aren't a thing. And if minutes aren't a thing, square minutes surely aren't. So what we want to do is take that back down to the units of the problem. If we squared it and we took it up to square units, we need to take that back down. But first, we're going to do another thing you mentioned. When we are finding the standard deviation, in general, the formula is that we take every data value and we subtract the mean. That's what we did in this column. Then we square all of those. That's what we did in the next column. Then we sum those all up. That's what we did down here. Next, we're going to do the next thing you suggested, which is we're going to divide by the total number of values in our data set, in this case, in the population of all your songs. And then the last move is going to be that we need to take the square root to get us back down to our units, because we were in square minutes, but we got to get back down to minutes. So what we just did in the table we just drew is this number here is this whole numerator. So we're just going to replace and write square root, and we're going to put in the 24.9763 on top. And then you guys remind me, what's the size of the population? How many songs does Moby have on this album?
11.
11, the best number ever. And then we're going to go ahead and see what does that come out to. So Moby, what is 24.9763 divided by 11, just in your head?
2.35.
Actually,
That's
it's
good.
pretty close. It's 2.2706. So that's pretty close. Your mental math is pretty darn good. And actually, this number underneath the root has a name, and Natalie will help us with that on the next one. But that does have a name, but we remember that that's still in square minutes. And so we still want to take the square root here. And when you take the square root of 2.2706, about what comes out? I want you to guess it again because I'm having fun with that.
4.8.
Try again. If you're taking the square root, you're going in the
0.48. 0.48.
It's
0.46.
All right. So you weren't so great on that one. I'll edit it out. It's fine.
Wait, the square root, sorry, because the square root of 2.2.
Like
okay.
The square root of 16 is like 4.
Yeah. So
Yeah, that's why I thought the square root of
Yeah.
22 was the way I was thinking of it.
Well,
So like, because 2.2 is a little bit, is like the square root of 25 is 5. The square root of 16 is 4. So I assume that the square root of 2.28 or 2.27, but maybe I'm
here, this kind of helps me with the mental math part if I'm not going to use a calculator. Actually, let's not do 2. Let's do 1. I'm going to take 2 perfect squares that are in like numerical order. What's the square root of 1?
I don't know.
Yes, you do.
1.
1.
What? What's the square root of 4? What number squared yields 4?
2.
Cool.
Oh, okay, now I get you.
Yeah.
Okay.
Our number is, I'm finishing my thought, 2.06. So when you take the square root, it's between those, if 1 is between, 2.27. Yep. Yeah, okay. All right, fine, Moby.
Right there with you.
All right. So makes sense that we get the 1.51 minutes. And so what this is telling us is this is the typical deviation of one of your songs from the mean. So that's how far your songs tend to stray from that middle. Some a little more, some a little bit less. Natalie, do you want to help us with the next one?
Yes. So what is the variance? Like you were saying, that's the standard deviation squared, which we kind of already have that number sitting there. That would be that 2.2706.
Mm-hmm.
And the units on that would be minutes squared, which like we were saying before, that's a little bit hard to interpret what minutes squared means. But this is just like another measure of spread.
Right. Also, I want to point out that if you actually take your rounded value here, because a lot of the time people do just take the standard deviation they just calculated and square it. If you take that 1.51, which we rounded, and you square that, you're going to get an approximation to your standard deviation or to your variance. and it'll be a little bit off. I'm getting like 2.2801 if I do that. So if you're gonna do that, you're gonna want to take this out with more accuracy. And also note this would be an approximation. So if you're trying to find your variance, the best way to do it, making the least amount of error, would be just to find it inside of your work. So it's the value before you take the square root. A lot of people will proceed to take the square root and then take that result and square it, and you're just accumulating round off errors. Yep. But if you don't find the standard deviation by hand, then you're not going to see that variance in there. Like you're not going to have, and our calculators don't give it to us. So before we go to the next thing, maybe we should look at the calculator and see what it gives us and how we can manage that. Because after we do a few of these by hand, like that was really fun, but do you guys want to keep doing these by hand for like fun on the weekends?
I'm good. I'm good on that.
I'm good. What about you, Moby?
I mean, I think it's safe to say I'm never going to do this again as long as I live. So, yeah.
Okay, well then why don't we figure out the fast way to do it, and then next time you're meeting with your accountant, you can be like, oh yeah, the standard deviation is 1.51 clearly, and you can just kind of spook him a little bit. So what I did is I went ahead and put the data into a list, and then this is the part where the class gets mad at me, because you'll see how quickly we could have gotten that value if I had told you about this first. There's our average. The calculator will always call it X bar. I translated that into mu because it's the population of all your songs. And then see this little guy down here, the standard deviation of X being about 1.51. Yeah, so that we can just get it that fast. The calculator can do it for us, and I want to encourage people to do that. The only bummer with the calculator is it will give us the standard deviation, but it does not give us the variance. So if you need the variance, you have to take this value and square it. And so to do that, take it out as many decimals as you see for more accuracy, so you don't get like marked wrong on the software for your homework. A lot of people think the SX is the variance. That's not. That's the standard deviation if we were working with a sample, but we're not. We're working with a population of all your songs. Cool.
Hi, I'm Moby, and one of the songs on my new record is My Only Love, which is a cover song from the band Roxy Music with Brian Ferry. It might be interesting to see how a song comes together, because I'm just one little guy, and I make records here in my studio by myself. So with this particular song, it started with acoustic piano. In fact, I started playing the acoustic piano line before I even knew it was going to be the Roxy Music cover. So I recorded the acoustic piano line to a click track at 125 beats per minute, not really knowing what I was going to do with it. And then I added some program drums, just like a simple kick drum. And then I decided to record live drums because I really love electronic drums, but I also love electronic drums when they have sort of a live element as well. And I'm not a great drum recording engineer. In fact, on a lot of my records, the way I've recorded the live drums is just two microphones sort of in the room on top of the drums, room mics or overheads. And that way I don't get like what would be considered technically a great drum sound, but it gives that live element. So far with this song, still not knowing it was going to be My Only Love, I had the piano line and kick drum and a little bit of programmed drums, and then live drums to give it some sort of organic movement and energy. And then I decided to add new wave live bass. And for me, what new wave live bass means, it's very much inspired by Peter Hook from Joy Division and New Order, is basically using the bass sort of like a distorted live lead instrument. So I recorded two aspects of it. There's the low live bass and the high live bass. And the low live bass anchors it a little bit more. And then the high live bass is a little bit more of a lead element. Both are distorted and run through flanger a la Peter Hook from Joy Division and New Order. After that, I decided this was actually like a nice piece of music and maybe I should turn it into an actual song. So originally I tried writing my own vocals to it and they weren't great. And then I was listening to a Roxy Music playlist and I heard My Only Love and I thought to myself, this isn't too dissimilar from that song that I was working on. So I came home and I added my own vocals, which we're not going to include in this how-to tutorial. But I added my scratch vocals, realized they were not very good, and then I got my friend Mindy to sing the lead vocals. I would love to show you Mindy singing the lead vocals, or for her to walk into my studio and say, hello, the problem is we're under quarantine. So instead, here's a picture of Mindy, and of course you get to hear her beautiful voice.
My only love, my only love, my only love, my only love.
So at this point, I have drums, bass, live piano, and Mindy's vocals. And so then I wanted to give it a sense of grandeur. So I added a whole bunch of strings and synths. And what I like to do is record, like take almost like the same MIDI part and repeat it multiple times over different synthesizers and different string libraries. So you get this, it's an orchestra. It's, a whole bunch of different instruments playing roughly the same part. So I recorded these, big, hopefully epic sounding strings. One of my favorite instruments that I've had, actually I think it was one of the first synthesizers I ever got, is a Korg Micro Preset, and it's an analog synth, and I just love it, and I use it constantly. So I added some Korg analog synth parts on top of everything. It's got a very vocal sound, so I didn't want it to compete with Mindy's vocals, but you can hear it sort of interwoven throughout the track. And then one of the last elements I added, because I feel like I am an electronic music cliche who grew up listening to Kraftwerk and Afrika Bambaataa and other music that used a vocoder. So I added a vocoder part where basically you sing into a microphone and it goes through filters and oscillators in a keyboard, an analog keyboard, and what you play on the keyboard is what comes out as the vocoder part. So that's how I made this song, My Only Love. Thank you for watching, and I hope you enjoy the song.